Recitation problem 3. Two arrows are shot vertically upward. The second arrow is shot after the first one, but while the first is still in its way up. The initial speeds are such that both arrows reach their maximum heights at the same instant, although these heights are different. Suppose that the initial speed of the first arrow is 25 meters per second, and that the second arrow is fired 1.20 seconds after the first one. The question is, determine the initial speed of the second arrow. First, let's write down the information for arrow number 1 and sketch its motion. Alright, what do we know about the arrow number 1? Its initial velocity is equal to 25.0 meters per second. That's known. We know that the final velocity, let me write down v01 here because I have two objects moving. The v final, which is at the highest point for arrow number 1, is going to be 0. I'm going to write v1 also. 0. We know at the highest point the velocity is 0 because the objects they come at perfect rest. And here is the object going up in the air and is going to end up at the highest point with 0 velocity. Now, since the gravity is known, gravity equals 9.8, we should be able to solve for the time is going to take the object to reach the highest point. If you know the final velocity, initial velocity, that's a very easy task. v1 at the top equals v01 plus negative g times t. Substitute the known quantities and solve. This is 0. This is 25 plus negative becomes negative 9.8 t. Solve for the time. Solving for the time, you get t equals 2.55 seconds. I'm going to label this time t1 specifically for the first object. Now let's focus on object number 2. The initial velocity for object 2 is not known, and that's what we're trying to solve for. The final velocity is going to be 0 like before. The g is 9.8 because the object is in a free fall motion. Here is how the motion of object 2 is sketched. Is launched with the v02 velocity that is not known to us, and that's what we're trying to solve for. Is going to a given height, maximum height, where the velocity is going to be 0. Notice when this object 2 reached this height here, the other one reached the highest point exactly at the same time. And that's the reason why that one went higher and this one not as much. Okay, in order for me to solve for this v02, I need the time. That's the missing piece. So let's try to figure out a way to find out what the time is equal to. Notice that the second object is launched 1.20 seconds after object 1. And we already know how much time it took object 1 to reach the highest point, which is 2.55 seconds. Therefore, the time for the object 2 to reach the highest point, I'm going to call it t2, equals the t1 minus 1.20. The simple reason is the second object is launched after object 1 1.2 seconds behind. So we needed to subtract that time. So 255 is what we solve it for, minus 1.20. The answer for T2 is going to be T2 equals 1.35 seconds. Now that we know the time t2 it took the second object to reach the highest point, it's very easy to solve for the initial velocity. The final velocity equals initial velocity, that's for 2, right? Plus negative gt. The final velocity we all know is going to be 0. The initial velocity is what we're solving for. That's negative 9.8. The time is 1.35. Solving for the v02, we obtain v02 equals 13.2 meters per second. And that's our answer right here.